Hi everybody! In this video we're going to be moving into polynomials. So this video is going to talk all about what polynomials are, how they're written, and then different types of polynomials. Okay, so the first thing is, what is a polynomial? So the definition of a polynomial is an expression, an expression consisting of many terms. Make that a little bit bigger so you can see it. So a polynomial is an expression consisting of many terms. So examples of polynomials. Sometimes it's easiest to talk about things through examples. Examples of polynomials. Well, one is just the number 5. Any number, any single number can be a polynomial. Negative 6x. So a term with one variable and one constant, that can be considered a polynomial. Another one would be something like 4x squared minus 1. Two terms, the 4x squared and then the 1, those are two separate terms, polynomial. We can also do something like 9x cubed plus 4x squared minus x minus 2. So that is also a polynomial. This whole thing. So this is a polynomial. Each one of these is called a term. So the terms are separated by our plus and minus signs. So a polynomial is many terms. So poly means many. Polynomial, these are each term. So many terms put together with addition and subtraction symbols. So, a little bit more for definitions. Standard form is the way that we write polynomials. So the way we're going to write polynomials is that they must be written in alphabetical order with the highest exponent first. Right. So they must be written in alphabetical order with the highest exponent first. So we're going to do some examples about what standard form looks like. But just to get started, make sure you have all these definitions. So again, a polynomial is an expression consisting of many terms. That's our definition. Examples: constant numbers like this, a coefficient with one variable, one term. Here we have two terms separated by a subtraction sign, a minus sign. And then here we've got 4 terms. This is also a polynomial with 4 terms. We're going to talk more about that in a minute too. Standard form of a polynomial. So we talked about standard form of linear equations, ax plus by equals c. Well, standard form of a polynomial just means that we're going to reorder our terms such that it's in alphabetical order in case we had different variables, and that the highest exponent is written first. So you can actually see it in this example. This is standard form. They're all x's. Then we have an exponent of 3, an exponent of 2. This is technically an exponent of 1. And then this has an exponent of 0, x to the 0 power. So we're going to be working more with standard form on the next slide. All right, so this page, or this slide, is asking us to write these polynomials in standard form. So remember, for standard form, they have to be in alphabetical order and with the highest exponent first. So this, if we look at number 1, technically 3 to the x is x to the first power. If we don't see an exponent, that means it's been written, it has an exponent of 1. This 1 here is the one that's a little tricky, because you're going to say to me, but Miss Evie, there is no exponent, there's no variable, so there's no exponent. Well, remember that any exponent, any number, any variable, anything that has an exponent of 0 is equal to 1. So if I take this 1 over here, this is the one that I'm pulling from here. This is that one. This is really the same thing as 1 times x to the first power, or 1 times 1. So this 1, I'm actually going to circle it in green this time. This one here does have a variable. It has that variable x, but it's x to the 0 power. So if I'm putting them in order, I would put the exponent of 2 first, the exponent of 1 second, and the exponent of 0 last. So to rewrite these in standard form, I'm going to start with the biggest one, the biggest exponent, 2x squared. Then I'm going to add the one that comes next, which is that x to the first power. It's positive because there's no negative out in front, so this is plus 3x to the first power, plus the only term that's left is 1. So this is number 1 written in standard form. Let's take a look at number 3, thinking about it the same way. So our first term, the biggest exponent, our highest exponent, is this w cubed. That's what we're going to write first. The next one in descending order is this w squared. That's the term we're going to write second. This over here is w to the first power minus w to the first power, so we're going to write that third. And remember, this one is actually w to the 0 power. It kind of cancels out and makes it 1, so we're going to write that last. That constant value that doesn't have an variable is always going to be last. That's something you can hold on to. So we're going to rewrite. W cubed is my first term, plus 5w squared is my second term, minus my third one here is going to be minus w plus 28. So now I've written this polynomial in standard form. All right, number 5 is where things get a little bit tricky. So alphabetical order was the first rule, which means we need to look at the A's when we're trying to determine what order to write this in. So I've got an A here, an A here, an A here, and then there's no A in the last one. So we are going to order these based on the variable that comes first alphabetically, based on the A's. So the A with the highest exponent, with the greatest exponent, is this A cubed. I'm going to write that first. A cubed is my first term in this polynomial. Sometimes it's helpful if you're trying to rewrite these. I find it can be helpful to cross them off as I rewrite them. So we've already done the A cubed. The next A with the next highest exponent is going to be this one, 5a squared plus b squared. This is going to stay positive, so I'm going to write plus 5a squared times b squared. We can cross it off. That's gone. The next term with the next highest variable, exponent on the A, is this one, 2ab. That A is an exponent of 1. So this is a positive because it's not written otherwise, so we know that that's going to be plus 2ab. We're done with that one. The last term we're going to write is the last one in the list. This is technically a to the 0 power, which is 1. That's what we could kind of pretend is in there. So this is going to be minus 2b cubed. And that's going to be my final answer for number 5 in standard form. So now that I've done numbers 1, 3, and 5 in the notes for you, I would like you to try numbers 2, 4, and 6 on your own. What's kind of neat where we're headed is that different polynomials are called different things, and there are a couple different ways that we can name polynomials. The first way we can name them is based on their degree. So the degree of a polynomial, I'm going to write it here for you, is the highest power of the variable. So when you're looking at an expression, say we had something like x to the 4th plus 2x cubed minus 5x squared plus 3x plus 7. If we look at that polynomial, the highest power, the highest exponent is the 4. So this polynomial, this example that I've given you up here in blue, that polynomial has a degree of 4 because that's the biggest exponent in the polynomial. So when we look at the degree of a polynomial, depending on the highest degree, depending on that highest power, there are different kinds of polynomials. If we have a degree of 0, that is a constant polynomial. So an example of that would be if we had the number 6. Remember in the last slide I said that anytime we have just a constant number, we can imagine that there is an x to the 0 power next to it. that x to the 0 power is just 1. So a constant, you might be thinking, well, a constant number, just a number, doesn't have an exponent, but it kind of does because of that 0. Anything to the 0 power is 1. So a million to the 0 power is just 1. So anytime you see a constant number, a number all by itself, we can imagine that it has a variable or letter x to the 0 power, because that 0 power makes the variable kind of go away. It becomes 1. All right. A degree of 1 is going to give us a linear polynomial. You guys are super experienced in linear polynomials now. This is something like 3x plus 5, right? This has an exponent of 1 on the x, so that's a degree of 1. And you know exactly what that looks like. If you were to put that, if that was y equals 3x plus 5, you'd be able to put that on a graph, and it looks like a line. You guys have a lot of experience with that. If instead we have a degree of 2, that is a quadratic polynomial. An example of that could be something like x squared minus x plus 2. That is a quadratic polynomial because of this exponent of 2. That is the biggest exponent in all three terms. A degree of 3 is going to give us a cubic polynomial. So again, x3 plus 2x plus 7. This has the highest degree, the highest exponent we have is the 3, which makes this a cubic function. If we have an exponent of 4, that's the one that we don't typically talk about, we don't work with them a lot, but that is called a quartic function. Quartic. So x to the 4th plus 3x cubed minus 2x plus 1. The highest degree on those x's is that 4, making this a quartic function, quartic. Okay. The other way that we can talk about what kind of polynomials we have is the number of terms in the polynomial. So if we look at our constant function over here, we just have a 6. There's only one term. Or something like 3x. If that's all we have, that's one term. The prefix mono goes with 1. So a one-termed polynomial is going to be called a monomial. Okay, 2 terms. Just like the expression on the other side, a linear expression, 3x plus 5. There are 2 terms, 1, 2. So the prefix bi, think about bicycle, biped, all of those things, it means 2. So a polynomial with 2 terms is going to be a binomial. Okay, then we go down to 3. We'll use the expression on the left, x squared minus x plus 2. That's our example. This expression has 3 terms, 1, 2, 3. Think about tricycle, right? That prefix tri, meaning 3. So a 3-termed polynomial is going to be a trinomial. Anything that has more than 4. So 4 or more, sorry. So say, I'm going to write it down here. I'm going to use the expression from the left. X to the 4th plus 3x cubed. I'm actually going to add to it minus x squared minus 2x plus 7. Say we have that one. On this, I have 1, 2, 3, 4, 5, which falls into that 4 plus category. But any polynomial with 4 or more terms is going to be a polynomial. Poly meaning many. So we only specify if it's 1, 2, or 3. Anything larger than that can just fall into that grouping of polynomials. All right, so for numbers 7, 9, and 11, and on your own 8, 10, and 12, the directions are to classify the polynomial based on the degree and the number of terms. So if we look at number 7, you can see we have this, all we have is a 6. So with the 6, technically, that means we have a variable with a degree or with an exponent of 0. Remember, we said that this becomes 6 times 1, or just back to 6. So the degree on this polynomial is a degree of 0. So that is our constant degree there. Since it's only a 6, we're not adding or subtracting anything else. There is only one term in that whole thing. So we are going to classify number 6 as a constant, did it again, sorry guys, as a constant monomial. So just the expression 6, for example number 7, is a constant and it is a monomial. Okay, so let's take a look at number 9. We have let me do the degree first. For the degree, this p technically has an exponent of 1 on it. There are no other variables, there are no other exponents, so this expression has a degree of 1. If we look in the chart, a degree of 1 is going to be a linear function. So we can start with that this is a linear polynomial. Secondly, we want to look at the number of terms. Here is one term, and here is a second term, being separated by this plus sign. So if we look in the table, 2 terms is a binomial. So not only is this polynomial linear, it is also a binomial because it has the 2 terms. Okay, we're going to look at number 11 the same way. So number 11, the biggest exponent we see is this 3. So if we go down to the degree, so that if we go down to the chart, the degree of 3 gives us a cubic function. So this is a cubic polynomial. Then we need to look at the number of terms. This one has 2 terms separated by a minus sign. So we want to go back down to the chart, and a polynomial with 2 terms, we've already used it once, that is a binomial. 2 terms, binomial. So you are going to do the same things for numbers 8, 10, and 12 in the notes. Please let me know if you have any questions.